Hi, this is Ambika, Assistant Professor, Department of AIML. Today we are going to discuss about the socio-technical systems and critical systems specification. Socio-technical system. Here, socio-technical system are nothing but they interact with the people, organizations, procedures, and hardware. Normally, the modern software systems they do not operate in isolation. So, in critical applications, the failures may lead to loss of life, property, or environment, and also they require the critical system specification. Socio-technical system, it includes the technical systems which involves hardware and software. Social system involves people, processes, policies, and also the organizational structures. So both the parts, they must work together to achieve the system goals. Components of socio-technical system. Technical components are software, hardware, networks, and databases. Social components includes users and operators, management, organizational rules, work practices, and also legal and ethical constraints. Characteristics. So they involve the complex and large scale, dynamic and continuously evolving, influenced by the human behavior, and also the interactions will be unpredictable. It is also difficult to fully automate. Examples. So air traffic control systems, banking and financial systems, healthcare management systems, smart transportation systems, and e-governance platforms are the examples of socio-technical systems. Importance. So here the system success, it mainly depends on the human acceptance. Only the technical excellence alone is not sufficient. So the poor integration, it may lead to the system issues, security breaches, as well as the operational failures. Challenges. So it conflicts the stakeholder goals. It is resistance to the changes, informal work practices, and organizational politics will be happening. It also leads to the ethical and legal issues, and also it leads to the security and privacy concerns. Critical systems. A critical system is nothing but a system where the failure may result in injury or loss of life, severe financial loss, environmental damage, as well as legal or regulatory violations. So the types of the critical systems are safety critical systems. So here this failure may cause due to the, it may cause the loss of life or injury. Example, aircraft control system, nuclear reactor system, medical devices. Mission critical system. Here in case of mission critical system, the failure leads to the mission failure. So example, space missions, military command systems, emergency response systems. Next is business critical systems. Here the failure leads to the financial or reputational loss. Examples, banking systems, e-commerce platforms, and stock trading systems. Critical system specification involves precisely defining the system behavior, ensuring the safety, reliability, and security. Safety is nothing but even the system failures, it should fail with the safety. Next is reliability. The system should run without any error at least for a specific period of time. Next is security. So it also follows some security concerns. Next is preventing the ambiguous or incomplete requirements. Key components of the critical systems. Dependability requirements. So it mainly focuses on the availability, reliability, safety, and security. Risk-driven approach. It involves identifying the potential risks, analyzing them, and also classifying them. Next is functional requirements. So it defines the error checking, recovery of the facilities, as well as protection against the system failures. Non-functional requirements. So here it specifies a quantifiable metrics like mean time to failure or probability of failure on demand. Next is safety or security constraints. So normally they define what the system shall not do. For example, the system should not allow the reverse thrust mode when the aircraft is in flight. Next is requirements of the critical systems. It should be complete and consistent, precise and unambiguous. It should be verifiable and also testable. It also should be traceable. That is, the requirement should be traced in all the phases of the SDLC, and the documentation it should also be done formally. Specification techniques. Formal specification. It uses the mathematical notation. It removes the ambiguity. It enables the formal verification also. Examples, Z notation, BDM, the Vina development method is a formal method, and also B method is followed. Semi-formal models. Here UML diagrams, that is Unified Modeling Language diagrams are used, state machines, and also the sequence diagrams. Safety requirements. So it defines what the system must never do. It mainly focuses on the prevention of the hazard. For example, the system shall never allow conflicting the train signals. Next is fault tolerance specification. Here it describes the behavior under the failures, which includes redundancy, fail-safe mechanisms, as well as the recovery procedures. Socio-technical considerations in the critical systems. So here the human errors is a major risk factor, and also if you consider about the training and procedures, they are also part of the system. So here clear roles and responsibilities, they are essential for the socio-technical considerations, and also if you consider the user interfaces, they must reduce the cognitive load of the system. Thank you.